lot of headway into implementing backprop. I have so much trouble always saying these words. RNN, LSTM, backprop, whatever. Now let's attempt to add backprop. We may not get it done today, but let's at least start. We might have to pick up tomorrow, but that's fine. So right now what I'm doing is I'm just going through Geeks for Geeks. Amazing resource, I think. We've already implemented forward pass, using them as what's the word I was looking for? I forgot what I was trying to say again. Here we go again, Mr. Forget Ahead. So I'm using Geeks for Geeks as a reference, looking at how they implemented their backprop and then doing the same for my code. What I'm doing is I'm just going to go through, I'm just going to make sure that all our labels are aligned. Now that we've labeled everything according to the Geeks for Geeks article, what I'm going to do now is I'm just going to implement backprop as mentioned in the article. Do we need to put this through a softmax or any type of activation? Oh, that's a good question. Let's try it out. Let's experiment. And if it doesn't work, it doesn't work. See, the reason why I'm getting a little confused is because in the RN, I can never say this correctly. In the RNN, what we do is we then pass our raw output, we then pass it through a softmax activation. But here, it doesn't look like that's the case. I'm just going to keep it as is, and then we'll figure out how to add softmax later. I honestly cannot be bothered. I'm a little nervous to implement this because there are like typos in this, so it just makes it very hard to trust and know that the code is accurate. So much math involved. Okay. Very nervous. This may not work out at all. Okay, now let's start actually backpropagating into our weights. So if everything here works as expected, this should not be an issue. Then we take gradient with respect to forget gates. Oh my god, the end is in sight. The end is in sight. We're almost there. We just have this forget gate to do, and then we should be good. I just had a scary realization. Even if we do have the gradients, how do we actually use that? Okay, so something's wrong. Of course there's something wrong. So these are the final gradients, and these are what we're supposed to be adding to our weights to update them. But remember, this should be a 4x4 because our weights are a 4x4. So I'm only getting 1x4. Ugh. One thing I noticed just towards the very end here is that this article is great in that it lays everything out for you and makes it very easy to understand. But one thing that they didn't necessarily do is differentiate between when there has to be a normal multiplication or a matrix multiplication, like an element-wise multiplication versus a matrix multiplication. That's the only thing that they did not specify. Actually, I think it's actually quite simple. Boom. Okay, there we are. I guess we figured it out. For anyone who really wants to know what I've done here, E delta times O times, like this statement here has to be a 4x1 because it directly influences the bias. Remember, the bias is a 4x1 matrix, right? So right here, bias is 4x1. Remember, the only time we do matrix multiplication is when we're actually multiplying it by either x or ht. That means that this here is matrix multiplication. Remember, the way I've done it is I flip things around. So I have to multiply x at the very beginning and ht at the very beginning for me in order to make the matrix multiplication compatible, or the matrices compatible with each other, because this is a 1x4, the input is a 1x4, so I have to transpose that, make it a 4x1. 4x1 by 1x4 gives us a 4x4 matrix, which is exactly the dimensions of our weights. Boom. Okay, so now that we're done that, we just need one more, and then we're Gucci. One more, we're almost done. I am excited. DEDG. Okay, so, and just like we did with the RNN, what we're going to do is we're going to roll it back up. And as we're rolling it back up, we're just going to keep adding the deltas to each other. And that's that. The deltas are just these guys here. So we've implemented forward pass. We've made a lot of headway into implementing backprop. I have so much trouble always saying these words. RNN, LSTM, backprop, whatever. Anyways, so we've made a lot of headway implementing forward pass. We've also made a lot of headway. Actually, we've completed forward pass, and then we made a lot of headway implementing backprop. So what I'll do is I'll stop here. We'll pick up tomorrow, and we'll finish backprop, and then we'll actually train our first LSTM, and we'll see where that goes. And hopefully, we'll be done with LSTMs this week. That's the aim, but we'll see.